I'm a technologist. I just spent the last 12 years in Chicago working for financial trading institutions, consulting, dot-com consulting during the 2000 time frame, a couple of failed startups, and most recently was at Orbitz Worldwide, where I was the chief architect over all the systems that we delivered for having the second largest online travel site, group of sites in the world. It was a great time. We went through 2 IPOs, 2 acquisitions, 2 spin-offs, but increasingly, if anybody was here in the previous presentation of Michael, who was talking about how the kind of corporate inertia that it becomes more and more difficult to get things done, that slowly took over, and it got to the point that things were not all that agile. There was all too much work, a little bit very technical for me, and not enough play. So I decided to go for a bike ride. I rode from Mexico to Canada, and had a lot of time to think while I was on that. And one was I wanted to live in a beautiful place like this, close to the outdoors, but 2 was that I needed to get back closer to technology and take some of the lessons I learned from these other places. And search for a startup, somebody doing something interesting and innovative that I could join. And that's how I found the Small Energy Group. We build real-time energy management software as a service. We're based in Vancouver. As of yesterday, we moved downtown from West Vancouver. And I started there in January. And since then, we've rebranded from Small Energy Group to Pulse Energy. The team's grown. We've got a tester, a product manager, a graphic designer, 10 technologists in weekly deployments. We push to production every Wednesday night. And it's been great so far. It's a good place to experiment with other like-minded individuals. People may know Owen Rogers from sitting up here in front today, who's also emceeing and doing the intro. He's spoken about a lot of our practices. Last year, Jeremy Goldstrom spoke here about what we're doing. So it's been a good place to try out some of these new things that I've always wondered about. You know, things didn't quite work the way that I thought that they should at Orbitz or other places. And so we've had the opportunity to try something that Werner Vogels from Amazon calls the 2 pizza team. This is really the fact that you've got everybody you need, all disciplines on one team. And sometimes that's difficult, but maybe you don't have a guy who's an expert DBA, but that's the way that it is. You get creative. You don't care that you don't have a DBA. You find a way to solve the problem, because what you do have is the responsibility to get a system out there in production and running. And so when I came to Pulse, one of the things I kind of looked back on was previous jobs. At Swiss Bank, we supported trading I built trading applications. And we had a small, dedicated set of support teams that were dedicated to maybe 2 or 3 applications. And it was a pretty good relationship. We knew the teams well. It was maybe 20 of us total. But it worked really well. When I was in consulting, that was a completely other story. I mean, it was 1999, and people were throwing money at things. The consulting managers were saying, write the code, throw it over the fence, move on. We've got other projects to go and solve. It didn't feel good being in that kind of environment. That wasn't the way I wanted to practice my craft. I was at a startup. Startup was really that field that I liked, where we were able to, everybody pitched in and contributed, and we did whatever it took to make things run. And unfortunately, it was a great place, full XP shop. We enjoyed what we did, but it didn't make it. So that was when I moved on to Orbitz, and it started out as a fairly agile place. We were releasing every week at the beginning. And slowly it slipped to 2 weeks, and 3 weeks, and maybe 5 or 6 or 7, and finally kind of 9-week cycles by the time we were done. And the line from the code that I wrote to production was that there was a frontline support in a network operations center, the NOC. There was a whole team just for deploying code. There was an app support team that took care of what the NOC was unable to answer. And then we might get called as developers. And we had a boatload of functions and features that we were always trying to implement. So we didn't really get to see things through and see our features out in production. We were too far away from it. And that was something that I wanted to stay away from. So I went back to where a small team was responsible for everything. There's no hiccups with handoffs. When something doesn't work, you're the team that did it, you're the team that feels the pain, so you fix it, you make it go away. There's no blame that can be placed. That was the kind of environment that I wanted to work in. So when you think about separate development and operations teams, there's different team values and goals. An operations team oftentimes they're focused on stability. They want to keep things running. They don't want to see anything change. On the other hand, the development team, they've got a backlog of features. There's change, constant change. They want to get something out there and add on to what's there. Direct opposition to what the operations team traditionally wants. Operations team likes predictability. They want to know the same thing happens. It's easy to know what's going to come next here. When there's uncertainty, that means the pager goes off in the night. They don't like that. On the other side, from a development perspective, experimentation is what we're all about. Let's try something, especially in the Agile world. Let's throw it out there, let's get some feedback, let's learn. Let's see what happens when we push a little faster when we go to the other side. What's going to come of it? So it's really this question, or it's set up development versus operations. And it seems really unhealthy. Unhealthy both for the teams and for the system that we're running. So is there a way that we can turn that around and find something that will work for both teams? And so it's kind of interesting that Martin was speaking earlier about the Agile Manifesto and semantic diffusion, because one of the things I had done was look at a couple of the points. I read through the manifesto and said, it's very Agile development focused. Is there anything we would need to change to make it for Agile DevOps team focus? And really, most of the principles remain the same. This is a little dark here. But really, it may be kind of semantics a little bit of arguing whether or not software or a system or delivering versus deployment. But it doesn't really take a whole lot to adjust all the goals and things that we want as an Agile development team to work for an Agile DevOps team. And so with that, let's move on to actually what happens when you've got a unified DevOps team. This is kind of a two-tier stack, a database machine and a web app system that we're all pretty familiar with. Very simple, but in the real world there's a little bit more complexity. There's additional machines added for redundancy, and we can start to scale this out more, but this probably works as a good model that we can start to use today to figure out what are the concerns that we need to have when you're not only developing the code, but you're responsible for being on the front line with it. So we've got redundant web app servers, another box over there I've called utility, that maybe we run a warm backup database, spool our logs and things over there, but that's a box that you can kind of work on and not necessarily impact the rest of the production environment. So from kind of laying down an iron perspective, it's a good start. If we go forward, we can put some applications on there. Standard MySQL database, message queue service, Glassfish, Nginx. Similar, this is pretty close to the setup that we've got at Pulse Energy, and that's a lot of the application stack. If you were to show this to an ops guy, though, they're going to take a look back and they're going to say, there's a lot of holes there. There's some things that we're not doing. We're not monitoring or collecting any metrics. We don't know how that system's working. You've just kind of thrown it out there to the wild. We need a way to collect feedback on it. And so it means that we need to have a few tools that we can use for that. So what are the prerequisites for choosing a tool? One is that it needs to serve an immediate need. There's so many tools out there. If you follow any blogs or anything, there's something new that crops up every day. We can really get distracted. So we've really tried to live very simply, in that when there's a pain, that's when we look for a tool to address that. And go out and find something that will make our lives a little bit easier. So make sure that any tool we're looking at serves an immediate need. It needs to be compatible with our environment. As I said earlier, MySQL is our database. We're mainly a Java stack. We run inside of a Glassfish application server. There's Hibernate Spring. Fairly typical for what I think a lot of people are doing now for enterprise Java development. We've got Red Hat and Ubuntu Linux that's out there. Our developers are free to use whatever tool they're most productive in their development environment. So that means we've got people using OS 10, Windows, Linux. And we're starting to see some alternatives start to creep into the system. So Python, Scala, Groovy, branching out from just standard Java. So anything that we go out and add to the system needs to be able to work with what we've got. And we'll continue to adapt and evolve. I mean, I think that's, again, one of the basic premises of Agile is that we're not going to set anything in stone. We're going to continue to evolve. It needs to be a low or no-cost solution. Now, it doesn't mean that we wouldn't buy anything, any libraries, but we are a startup. This is not the late 90s. Money is a concern. We're worried about the burn rate, and that's something we need to make sure that whatever tool we've got, it can't be something that we purchase and become shelfware. It's if we try out some open source solution and it turns out to not be what we need a couple months down the road, it's a relatively low cost from a monetary perspective. From time and effort, that's another story. But we try to look at some other considerations of when we're looking at tools. One, is it open source? Because that's good. That means that we can go in, we can troubleshoot it, we can debug it. By having the source available to you, it means that inherently it's extensible, although hopefully there are already APIs in place that allow us to adopt it and make it work best in our environment. And hopefully there's an active community for it. If other people are out there using it, that means that they're going to be encountering the same problems that we are. That means that they're going to be looking to write the same plugins that we want and need. And together, we can leverage the power of the community as opposed to anything that's really homegrown. This is all, I think, preaching to the choir. We all understand the values of going with these types of tools. So with that is kind of our checklist for looking at tools that are out there. Where do we start? First, we just got to know the system's up and running. It's a bad thing when nobody knows that the front door is down. That happened exactly once when I was at Orbitz, that we had a customer come in and said that they couldn't get to the site, and the customer call center were the ones that told us. We learned very quickly that we needed to have something there telling us that the site was up and functioning. That was very early on. And so it was a lesson that was well learned. And so at Pulse we use Pingdom. Has anybody heard of Pingdom here? Anybody using Pingdom? This is essentially a distributed network of hosts around the internet that you can set up tests, and you'll be alerted via email. You can be alerted by SMS on your phone, and just recently, of course, it's nothing if it doesn't work with Twitter. So you can now get your uptime and downtime alerts sent to your Twitter feed if you want. But really what this is we're out there writing code as a development team. The site's running. The sales team is out there selling and demoing. This just kind of acts as a very simple automated process that's out there. We run it against our site. It's able to tell us is it up or down. We can do some slightly sophisticated things, log into the site and actually make sure that it's working. But gives us that first sense of, are things even running right now? Then for the end of the month or quarter or whatever we want to do, it gives us reporting that we can actually go back and see if we're improving or not. It gives us uptime reports and downtime in minutes so that we can see what happens when we have an incident. And really be able to go to management and say, you know what, we're having repeated downtime. Here's what we need to do. Here's the case why we need to spend some time working on these technical problems and maybe not some of the other product features. So it just gives us a lot of data points that we can come back with. Incredibly easy to set up. It's all web-based. It's a monthly or annual fee to have 5, 10, 30 checks that you pay. It doesn't add up to be that much, but you set it up on the Pingdom website, and then every minute they've got servers around the world that are pinging our site, letting us know that it's up and running, it's reachable. So definitely a plus for Pingdom that it's easy and fast to set up. On the downsides, reporting can be more flexible. There's the way that they batch up a lot of the reports all into one. It's sometimes difficult to get the information you want out on one particular check. We have multi-level checks that we're able to look at particular Glassfish instances, Nginx servers. So you might want to report on different things. It's kind of a little bit difficult. We've also seen some strange things with Pingdom where there may be outages in the general internet, that there's been some sort of segment. And so there might be servers in Sweden that can't see our site right now, and we'll get an alert about it. Whereas in general, here in North America where our customers are, all the connections are fine. But it works as a great, simple, easy, fast way to do first line of support. Log monitoring. So we know the site's up. How do we know that it's running? Anybody spend time when they come in the morning, it's the first thing that you do, go out and log into your production servers and just tail the logs? Too much is happening in the logs, I'm guessing that's why you can't see it. So it doesn't necessarily make sense to tail the logs. But this is something that was in place when I got to Pulse, and it was interesting because I wasn't sure what I thought of it initially. That on the app servers, there's these two daemon processes that run. The log master process is built on top of the logback package, and there's for anything that's a warning or critical, you can adjust the threshold. Anything that's logged through the system gets passed off to these daemons, and an email gets generated and sent to us. So generally the first response that whenever I tell anybody that, this has got to be what your inbox looks like. And if I think about a lot of the production systems that I've had in the past and I've worked on, it's true. Exceptions are being thrown constantly in there. But the downside of that is nobody's looking at those because there are too many of them. We're not opening up the logs and tailing them. When they're getting mailed to your inbox every day, every minute, you do something about that problem really fast. You don't let it decay. So it's actually been a really good motivator to help us go back and fix the system. Now, to be fair, we have exceeded our mail quotas at Gmail for relaying in the past. Our inboxes were really full. There is a throttling mechanism that we do have, that when there is an error that comes in, it batches up, and we may not see it. We won't see that message again on a predetermined basis of an hour, 2 hours, something like that. So we don't get swamped completely like this, because there are instances when something goes wrong with the system, and there's exceptions happening every minute. And it doesn't help anybody to have your inbox that full. So there's a goal that I think has kind of been a softly stated goal that we seem to be getting closer to, is that we'd like to be able to read our email on our iPhone when we wake up in the morning. If you can fit all those messages that came in overnight, we've got a pretty clean system that's running. But it's not an easy task. It's something that you have to constantly keep on top of. And so when I first started, one of the first things I said, I don't understand why all these messages are. What do they mean? Do we really need to see all of them? So we started putting together something that measures the signal-to-noise ratio. Let's figure out which of those messages really mean something, and we need to do something about it. Which of them are okay? Maybe it promoted discussions of, should that log message really be an error and critical? Or maybe it's only a warning, or maybe it's minor. It's forced us to have those discussions and start to agree amongst ourselves on our team. What do those different log levels mean? And when we see something that really isn't too critical and it's marked that way, we downgrade it and make sure that we really keep the signal high and are focused on the most important things. So from Logmaster, the pluses are that it results in clean logs. It's too painful not to clean up. But the downside is, it is something that we do have to maintain ourselves. It's built on top of Logback, and there's a little bit of effort that goes with that. Any questions so far? All right. Next up is Ganglia. Has anybody heard of Ganglia? Has anybody used Ganglia on their site? All right. So for those who haven't seen it, this is a great way to start to see trends of what's happening with your system. Sure, Logmaster is great for knowing what's happening at the time we get the emails, but there's a lot of viewing through those logs. If we can start to collect some of those, then we can start to visualize what's happening, see trends, and know what's happening. So Ganglia is an open source distributed monitoring system used by a lot of companies out there. Flickr, originally a Vancouver-based company here, but Twitter, Wikipedia, Reuters. It's pretty cool, actually. If you go to the Ganglia website, you can, they've got a direct link to the Wikimedia server Ganglia setup. You can see what's happening with all their servers. So lots of companies you've heard of are using it, and maybe some other companies you haven't heard of as well. But this is our Pulse Energy portal. that what happens is you come to it and you can see that we've broken down our grid into a couple of different layers, that web app layer on top and the database layer. And this is something that was a shot taken last week, and there's something interesting that's happening here. We've got this red line that suddenly goes up. Doesn't do anything in the web app layer. What that is that's measuring, when we look at the red line, the CPUs. We added a new server into the infrastructure that week. All we did was bring it online, ran the Ganglia process on it, and metrics automatically start being collected. It's really pretty easy to get things running. But number of CPUs, that's pretty static. That doesn't change that often. Hopefully we're not adding servers that often that we see jumps up and down in the number of processors. But there's also running processors, memory, things that are very dynamic that Ganglia can report on. So there's a couple of basic components. GMON-D, the Ganglia monitoring daemon. This is what runs on any server that you want to collect metrics from. It's just a little agent that's out there. Sits there, runs based on as a configuration file so that it knows what to monitor, and grabs all those metrics and then broadcasts them off to gmetad, the Ganglia metadata daemon, where aggregation takes place. gmetad is responsible for seeing all of those metrics that are out there, collecting it, storing it in an RRD format. I don't know if anybody knows or has used RRD, but it's a kind of a great fixed storage mechanism that things go into it on a minutely level, and then once things get older, maybe it's a week back, things are on an hourly level, and then after a couple of weeks it might go to a daily level. And so it gives you a way of keeping track of all this data without worrying about your storage requirements blowing out of control. Because how often do you need to really go back to the minute level a year ago? But all of that's the responsibility of gmetad. And finally, the last component that we kind of saw there at the beginning is it's called Ganglia Web. It's responsible for visualization. This is where the analysis of your system comes from. It's written in PHP, so it's just a simple Apache, Mod Apache plugin. And the whole system comes up and communicates by sending XML messages. The initial default setup is that you multicast across your network, so the GMON-D broadcasts out. Other GMON-Ds can relay it off to a gmetad if you need to, but it just kind of works. If you have network administrators who aren't too fond of multicast, you can configure it to work in unicast as well, but again, we're one unified team. We've seen no reason to disable unicast or disable multicast, and so that's what we're using in our setup. And so this is what the install looks like. We've got kind of our core production servers. All of them are running the monitoring agent. And then over here on the utility box, this is where I was talking about, this is all, we don't want to be affecting the system that we're measuring. So gmetad and Ganglia Web run over there. That's where all the metrics are stored. It's really a simple install. If you don't have to, if you're able to do a binary install, if you're compiling from source, there are a lot of dependencies for all the graphing. So if you're comfortable with building your own RPMs or rolling your own tarballs, it just takes some time, but it's relatively easy to get up and running. Once it is running, again, GMON-Ds are all either multicasting or unicast broadcasting all their information to the gmetad. A bit of work is done, it's collected, aggregated, and Ganglia Web is there for you to start to hit it. Yes?
Is the GMON-D cross-platform?
It's a C binary, so are you looking to have it run on which platform?
Say Windows.
I believe that they have gotten it to run on Windows. We are all Linux shops, so I don't know for sure, but I know that it's AIX, Solaris, and a bunch of those. So it wouldn't surprise me if through Sigwin or something they have been able to get it. Yeah.
On that same note, do you know if it's possible to get entry into Cisco here, like with NetFlow or anything, to try to get information off of something like that?
So that's something we'll talk about in a second, extensibility, that potentially there is that ability. But this is kind of how we've got it configured. And out of the box, batteries included, you get some pretty valuable metrics. I just went in and grabbed something from our site from a little while ago. You can see some interesting things here. I just grabbed disk space and load metrics. And you can see that every night or every day we're consuming a fair amount more disk space. This actually happens to be our database server. There's this odd bit here where there's a sudden spike in disk usage and then it goes away. It's also kind of this funny load average. There's a massive spike once a day. So if you look at that and kind of think, huh, I wonder what's happened. We have a power user that comes on doing something very interesting and cool with our system once a day. They log in. We can log in then and look at a weekly level and kind of start to see, huh, these spikes start to happen a little bit after midnight every night. I don't think that most of our users, knowing their profile, are up at 2 a.m. looking at the energy that their building is consuming. But I do know we do our database backups at that point in time. And so when you pull it off, all of that gets stored on disk. That accounts for a large file suddenly. And then in order to compress it and not take up so much space, we bzip it, which is incredibly CPU intensive. So looking at this, maybe there's something that we should learn about our system. Maybe we should move some of that off of that server, offload it onto the network, and move it over to the utility box. It's just interesting things that without any type of metrics and monitoring in place, we'd never know that there might be things like this that are potentially impacting the system. So, 500 pages. Sometimes they're humorous. Sometimes, even like Computer Fail Whale, they've become famous now. But I can tell you that from fact, I'm sure everybody else has as well, that when that 500 page comes up, and it happens to be for your site, and the CEO comes marching in and wants to know why, it's not funny, it's not humorous, and you want to do anything you can to make it, keep it from happening again. So this happened to us a little while back, that we had a mechanism that we're able to export data from the system. And what we didn't realize is that we had a user who really wanted some data exported, and he was exporting an extremely large data set. And we didn't have anything that prevented him from clicking it multiple times, and we didn't have anything way of signaling to him that this request was going to take a little while. And so, I don't know if anybody's read Michael Nygaard's Release It book that he was talking about when he started his presentation, but there's a stability anti-pattern of blocked threads. This was something we had. We didn't realize that one user was basically clicking so many times they were consuming all of our threads, our HTTP threads. We couldn't service any more requests. It looked like the site was down. And so we had to do something about it quickly, and that's where the extensibility of Ganglia came in, that we needed to add HTTP thread monitoring in our case. And Ganglia has a couple of extension avenues. There's a C API. There's a little utility called gmetric that you can run from a cron daemon. And then there's also a Python API. And so using that, any type of data that you can get your hands on, you can actually feed into the system and have it start to aggregate. So we wrote a little Python script now. We've abstracted out a bunch of the base work. But now for anybody to add a glassfish metric, they just need to add this one call here and create a method for it and know what the kind of JMX attribute is to access that from within inside of glassfish. Add that to this and it'll start appearing in the system. So it works really well. I lied, there's one other half. You do have to do a little bit of configuration. There's a configuration file that gets written, but unfortunately there's some duplication that happens between those two. It's something they're addressing in the Ganglia architecture. It may get fixed 2 versions out, but it's still relatively simple, so that anytime we do have a production instance now that we have to go and look at, we always try to do a 5 whys where we look a little bit deeper what happened. This is something that is available to us. That, one of the things we should know is how many HTTP threads are we using? Were we at the threshold before that we were just always ready to do it? So now what we do have is 2 charts that show us what the total thread count is and how many that are busy at that moment in time. So for your Cisco gear question, if there is a way that you can get into it, either through an SNMP trap or anything else, you could very easily feed that into the So the pluses of Ganglia, there's definitely a large community. It's well supported. It's built on RRD tool, which is used in big shops all over the place. Again, that constant data storage is a big feature, plus feature for that, because you don't want to have to be worried about the care and feeding of your monitoring system. If it's going and consuming all of your disk space, then it's just causing additional problems. You want it to be as low impact as possible. Ganglia is extensible. We're able to compile in, or add in lots of other metrics. We've got things from MySQL that we're able to download from the community. On the downside, the web interface is a little kludgy. It would be nice if you were able to modify it a little bit and save out some custom configurations. And it'd be nice to do something with more complex charts with multiple series. That's possible, we just haven't gotten to it yet.
Would Cacti be a good way to do that?
So the question is, would Cacti be a good way to do some of this? Cacti and Ganglia are very similar. I think that Ganglia is probably a little bit easier to get running than the distributed bit of it. Makes it a little bit easier. Cacti is what we used in orbits, and it served us well. So I think it's something that you can look at one versus the other and kind of make a call. Best for you. They're both
You
basic.
can't combine them together. Use Ganglia for the monitoring, collect the data, and then use Cacti to run the web front end, basically.
You could, because it is RRD tool that lays underneath. To be honest, I think that even Cacti could use a little bit of improvement in what it's got for when you look at some of the other tools that are out there that are maybe paid tools. We've got a ways to come in the world here. So the final tool that we're going to look at today is Puppet. Is anybody using Puppet here? All right, good to hear. This is the newest tool that we're starting to use at Pulse Energy, and so therefore I think it's probably the one that we still know the least about. So we're coming up to speed, but it seems like it's going to be really good because our system, it's out there, it's running. It was starting to get complex, and part of that is there's a bunch of configuration that needs to be managed. We've got this additional database server that needs to be managed. Puppet is really focused on how do we automate system administration tasks and manage configuration files effectively. And that's really the goal of the sweet spot. The other thing that it does is it hopefully helps to avoid and keep things under control. That sysadmins, it's often a black art of what goes on and what files have to get changed. And so sometimes when you're in the middle of a firefight of a production issue, somebody will go in and change a file, and the worst thing that can happen is that you forget that file got changed. And if it's part of the artifact of your application, and it doesn't get pulled back into the application or pulled back into source control, you deploy a new version, you deploy that bug all over again. Nobody wants to have the same bug twice. Same thing from a sysadmin perspective, that oftentimes all those files under /etc aren't under version control, and you start to have things start to sway or diverge from one machine to the next. Puppet gives you a way to start to centralize all of that and bring it in and manage it under one system. And so with that, there's just a couple of components to Puppet. The main one is Puppet Master D. This is the central repository where all of the recipes that manage your resources are stored. There's Puppet D, which is the daemon that works on every single server which you're managing configuration. It listens for updates from the Puppet Master and allows configurations that are pertinent to that particular node to be pushed to it. And then there's the recipes. These are what you write. The key thing to know about Puppet is it's all about resources. No longer are you managing your system by using a specific utility. You don't necessarily need to know file systems. All of that type of very OS-specific type of information has been abstracted away, and you manage resources. And then Puppet has the ability to go and say, this type of resource manifests itself on this particular type of OS or this particular type of system in this fashion. So it allows you, maybe you have a combination Red Hat Enterprise Linux 4 and 5 environment that you could manage the differences between those with all of the exact same configuration files. You know, Google uses it to administer all the Macs that are on their network inside of it. So it really allows you to not have to get into the details of the operating system, which as developers, again, we're trying to focus on delivering features for that application that is pertinent to our business. We really don't want to be spending our time down in the details of the operating system. So you write recipes for all the various things that you may want to manage, and then they get pushed out to all the nodes. So on our stack here, we've added these Puppet D clients that are listening, as well as the Puppet Master. And when the Puppet Master is running, it can push configuration out to all of those. And the key thing is it's constantly doing that. Another key concept of Puppet is idempotency. You need to make sure that the way you write your recipes, that they can be applied again and again and again. That it's always running. You should never do anything that isn't idempotent. So it's pretty easy to install. It's just a Ruby gem. And I think one of the things that's really very cool about it is, as developers, everybody I hope is using source control. So I don't know how many times I've been at places that Etsy is not necessarily under source control. This kind of forces it as you start to put everything in there into a recipe. It all gets managed with source control, so you can actually go back and see the log. You can see what's changed and know why things change, as opposed to just saying, resolve.conf on this machine is different than it is on this machine. And I don't know why, and nobody's commented it. You've got that running history inside your source control tool. Recipes are fairly easy. Again, this is for the Gmon D instance that we have. We've rolled an RPM that actually sits on our internal server, and we tell it to go get to puppet.pulse_energy. That's where you go to get that. And there's one configuration file that is responsible for configuring Gmon D. You can see that we actually have variables in here. A host name. You can do host name, environment. You can have different classes of machines, so web or database. So it is a programmatic language, which feels really comfortable as a developer, that I want to be codifying things and saying, if I'm in this type of environment, this is what I want to be pushed out there. And so on our file system, we have a bunch of files that just follow a naming convention where the host name is in there, and the right file gets pushed out to the right host based on that. And we can have things vary based on that. Host name is not always a good thing, because that does change. So more often than not, you would probably want to use something like an environment and a machine type. And we're starting to build that and bake it into our system. But the great thing about this is that I don't know if anybody's doing anything in the cloud. If you've got your entire system and server set up in a Puppet file, or your Puppet recipes, that means that you can bring up new nodes in the cloud relatively quickly. If you need to bring a new system online, even in your servers, it was something we did do frequently at Orbitz. When there was a fair sale that one of the airlines put on, we might know that we needed a bunch of servers out there to support something for American Airlines. We would bring additional servers online, and it was a very manual provisioning process. If we had a tool like this, it would be something that the system would be ready to go in a matter of minutes. Just one other example here, cron tabs, something that I think a lot of people always have to go and look and find out what do those 5 stars mean. They're rarely in source control. It's, again, a resource. It's all been abstracted out. Something very clearly, the command that you want to run, the hour, the minute, the weekday, you can use things like Monday and Tuesday, and it will translate it correctly into the proper cron tab format. So all of those things that are kind of cryptic sysadmin type things, there's a way to have it represented as a resource within Puppet, and you have a common way of seeing it in your system. So again, we're still early in our adoption of Puppet. One of the things is I think that we don't know how we're going to figure out exactly how to organize all of our recipes. It's something that's going to take some experimentation. If you look at the Puppet users group, you'll see that there's other people that agree. You don't necessarily want to have everything that's in cron in one particular cron tab resource, because you want these things to be grouped together. So if you've got something that logically runs as a part of another process, keep the cron job for that close to it. So it's something that I think we're still learning, and we don't necessarily have our practices down entirely or even our best practices. They're certainly not best practices. So with that, conclusions about this experiment of a unified DevOps team at Pulse Energy. We're still very early on as a company. We're still very early on in our experiment. Things are changing on a weekly basis, just as much as it does with every build. We're trying to iterate something here that we're always trying to improve something from week to week on the operations perspective. The Two Pizza team. We're starting to get hungry because just last week we had a big project that we released, and we did order pizza in, and we ordered 3 large pizzas. And so there was a little bit left over, but we are over that 2 pizza limit. We've started to break down in that we have 2 different teams that kind of operate, but I think we all still have a desire and a drive to know about everything that's going on. It's going to be a growing pain. It's going to be something we're going to have to figure out. I think the only answer that I do know is that we're not going to break down into a development and an operations team. We'll start to break down probably into functional teams that will have their own operations team, or people that maybe are more operationally focused within it. And along with that, we're also reaching this point where we're kind of balancing the need for specialists and generalists. And everybody does work on everything right now, but there's some hard problems that we know that we need to address. And we also, there's things as we're getting into managing our servers. Again, all of us are developers first and foremost. We've maybe played around with Linux machines at home, and we kind of have some ad hoc experience, but it doesn't mean that we're experts at it. And we could stand to have some expertise brought into the team. We need to figure out how we're actually going to get that expertise fully integrated without having them be time sliced across multiple teams. Next steps, Monet and Nagios are things that we're probably taking a look at. That these allow you to monitor and take action and alert at a process level. So it's not enough to know that the site is up and running. We need to know the particular processes, that log master process that sends out emails. Well, if we were getting emails and our logs were dirty, we'd know if it went down because their inbox would be clean, but when our logs are clean, we don't necessarily know if it's down. There have been times that we've asked, hey, is Logmaster up and running? No, the system's just running clean today. We don't have any errors. It'd be much easier if we had a dashboard we could go to and we could have somebody that shows, is it up or down, and better yet, takes action and brings it back up if it is down. With that, thank you for coming today, and if there's any questions, we can take those now. Yeah?
What about network security and things like that? Because that's fairly specialized, and it's analysts and stuff. Yours, like, the internet is your bread and butter, right? So network security is a primary concern.
It is something that is a primary concern. So we have our servers that are hosted at a data center, and that is one of the things that we do enlist our data center provider to help us with. So the whole front door, load balancer, firewall type of thing, we have their expertise. We have brought somebody on recently who does know the Cisco product line and iOS and all that type of stuff fairly well. I don't think that's going to be something that we're going to have people that are normally used to coding up Java classes take the foray into doing iOS management. But that's one of those things I think we need to learn. That, again, there is a specialist skill set there. But our solution right now is we have a partner that essentially helps us with it. Yeah?
We have sounds like it's similar to what you just described, where we actually have an ops team that takes care of the servers.
Okay.
They know nothing about the application.
Right.
And that works well for us, because we're not server guys. We don't know buying hardware, all that stuff. We don't care. But making sure things are running, that we do have that DevOps team doing, and nothing improves quality like getting calls at 3 in the morning.
Exactly.
Angry wives make for cleaner builds.
Exactly. I mean, yeah. If you feel the pain, you make it go away. So if that pain happens to be an angry wife, or that pain happens to be that you're one of those people who needs your 8 hours of sleep when the pager goes off, it's not going to happen too many times before you do something to fix it.
So do you multicast that pager message out to everybody on the team?
That's one of the things that I had said before, was that we have a rotating daily support duty. So we sign up for support 2 weeks out, and everybody signs up. Your first day of work, you sign up, and you may have a buddy that will help you through your first few rotations. But there is no better way to learn a system than to see it break down, or to have someone else in the company come and say, hey, is this working? Is this supposed to be this way? Get you up to speed, and that you have to ask those questions. And of course, the rest of the team is there to support you. But so there's one person who's always primary point on call, and when there is somebody that has built up an area, there's this pig and chicken analogy that's going around today. When you're the chicken and you need to have the pig, you know who the pig is, and you can call it in.
Who's involved in that rotation? Because one of the issues that I have seen is that the technical staff, who often don't make the decisions about quality being traded off instead of features, that sort of stuff, and they're saying, you know, we need to make this more stable, we need to make this more stable, but it's only them that suffers when the system isn't stable. So the business analysts or the sales and marketing, or even the executive, never pay the price. So how do you sell that? Because to me, that's the hardest part.
So one of the things that we've done is there's this notion of, well, I guess first we have a product manager who is very understanding. He's at every stand-up. He listens to what's happening. He feels the pulse of the room. And when there's a problem and we're all pulling our hair out because there's some hibernate bug that we can't track down, he knows that that's not the time to be saying, oh, hey, we need these 12 other features because there's something fundamentally wrong in the system. So I think first just having those people in touch and close enough to what's happening, that they understand it, they get it, that's a huge start. But then the second is, when we do have issues, I would say we're not as good at this as we would like to be, but we have a 5 whys procedure, so that it's kind of our root cause analysis. When there is an issue, they participate in that, and we say that on our wiki. It becomes very clear. You can see what were the things that went wrong. So that instance where we had a user that wanted to download the reports, there were lots of things that came out of that. There was one, we need to cache reports because we know they're going to take a long time to download. There was, you've got a huge usability issue here, and that people click a button, we don't give them any feedback. And then there was this, holy cow, we don't know what's happening with the system, how many HTTP threads are being done. So they participated, they heard all of these various solutions that we needed, or actions that we needed to take. They were filed into our bug tracking system, and they were then able to be prioritized with everything else. And when we need to make a priority call, we can say, all right, that's fine, we don't have to do that. We understand that the ramifications are that as people click on these buttons, that's going to be a bug that stays out there in the world that we're going to have to do. So I think it's really, again, it just comes back to kind of that agile way of working, that there's a lot of collaboration and open communication. Yes?
Actually, the way we dealt with that is our manager actually took on himself that one of his performance metrics that he's evaluating on is how many times we get called. So, you know, he's got a stake in it too. He's not just responsible for developing more stuff. He's also responsible for delivering more stable stuff.
That's a great way to do it.
You're on this very short deployment cycle. Out of that, presumably you're dragging all this off your source code and putting it out to your server. How long does that process take?
The process of deploying the system?
Yeah, you're taking all this new code. When you go to deploy it, live, what kind of time in your week is that?
It's pretty much a non-event. It's kind of maybe a half an hour. The longest part of it is actually uploading on our link to get it to the data center. That's a 15-minute part of the process, but we've scripted the rest of it that we can actually bring the site down and kind of do a zero downtime deploy. Based on, there are some changes that we cannot be zero downtime, but even for this database change that we made a couple weeks or last week, we just added a new functionality to the system. The site now has a read-only mode that we can tell our users we are in maintenance mode. We disable all edits and writes to the database. They can still view the data if we're making some changes to the database that are more substantial than that. But the great thing is that because we do practice every single week, it's something that we're actually pretty good at. Pretty proud that all we have to do is, I think there's maybe, it fits on a wiki page of 5 or 6 steps of this is what you do to do a deploy. Our summer interns and co-ops do deploys. People that are there their first week, oftentimes they take part in the deploy as well. Alrighty, well, thank you for attending today and enjoy the rest of the conference.